Hello everyone, welcome to ECE431 Lab, and this recording will go through the lab equipment, lab settings, the panels you're going to work with, and some equipment you're going to work with. And also I'll go through the procedures for Lab0 so that you can get an idea what is going on for that lab. In front of you is the lab bench that we're going to work with for one semester. And I'm gonna go through each of the equipment as we use them later in the lab. So to power it on, the main switch of this bench is right here. You turn on the bench, and notice all the equipments are light on, and they'll be ready to use. For Lab 0, it is the introductory lab. It will basically let you to touch everything we need for the future labs and let you to observe the behavior of the motor. Each time before you connect anything, you need to make sure the power is off for all the terminals on this bench. That is to ensure this knob twisting counterclockwise all the way to 0. And this switch is off. You also want to make sure the dyno control is off and the DC mains is off. If these switches are off and all of the terminals will be powered off. So now it's safe to do any connection. And also, remember, do not change any connections when any of this switch is on. The jump wires you're going to use for this lab is located on the left or right of your bench. For this part, we're going to focus on the top left or top right, depends on which bench you are working on, of the bench. So I'm going to zoom in here so that you can see this easier. So first of all, we're going to need a resistor box. Resistor box is under the bench. You have 3, but we only need to use 1 for this lab. There's a power plug for each of the resistor box. This is for the cooling fans, so make sure you put this cord on every time you use the resistor box. You can plug it right here. There'll be no light on the resistor box, but when it's plugged in, the fan will turn on once it's hot enough. The resistor box has 10 switches. Each of them connect to one resistor, and all of the resistors are connected in parallel. So each of the resistor is 500 ohms. If you switch 1 in, that's 500 ohms. If you switch 2, that's 2 resistors in parallel, which gives 250 ohms. And if you switch all in, it will be 50 ohms. So make sure you remember, the more resistors you switch in, the less resistance you get. The other 2 things we're going to use is the 3-phase power Variac, which is the big black knob to the left or right of your bench. So I'm going to move my camera a little bit so that you can see it clearly. This big knob is the 3-phase power Variac. So there are 2 columns of connectors for this knob. On your right is what you usually need to use. Those ones connect directly to this Variac, and the voltage will change as you turn the knob. The ones on the left, they are not connected to the Variac. They are directly connected to the 3-phase power, so you'll get 208 volt line-to-line voltage no matter where you turn the knob. So be careful, these terminals are with power when the switch is on, even if your knob is 0. These 3 little black knobs are the fuses for each phase, and they will melt down if there's an overcurrent in each phase. All right, let's zoom in to the other equipment that we're going to use. This equipment is a watt meter. It basically consists of a ammeter and a voltmeter. On the screen, you will see the different items you measure, and you can actually adjust them. Right now, it's showing voltage, current in milliamp, wattage, and then the power factor, and you're going to learn it in the lecture what the power factor is. Now finally we're ready to connect the circuit. So what we do is we let 2 lines coming out of the Variac, and they go through the wattmeter and they go to the resistor box. This simple circuit, let's connect it. make sure this switch is turned off. We have one line from A phase into the wattmeter, and then from B phase to the wattmeter, and then A phase coming out into the resistor box. This coming out to the resistor box. Now the connection is completed. And now we want to make sure we have one resistor selected. This is 500 ohms here. Now let's look at the wattmeter right here. First, we want to see this one is measure voltage, measure current, measure power, measure power factor. The second is we want to make sure here mode is the RMS mode instead of the DC mode. So let me quickly change that. So you press shift, press this mode, and then you'll change that from DC to RMS. And now I think we are ready to power this on. You can turn on this 3-phase main and then slowly switch this up. And now you can see the voltage is going up, current is going up, power is going up as well. Cool, huh? So now we are at top voltage, 205 volt. It's pretty dangerous voltage already. And then we get about 0.4 amp and then 81 watt. This resistor box is becoming a heater right now. And we got perfect 1 power factor. Power factor range from 0 to 1. So we got a perfect power factor because it's a purely resistive load. So it makes sense. This is the numbers you're going to see when you connect this circuit. To turn it back down, you slowly make this back down, and you see the voltage is gone, and then turn down the 3-phase main. Okay, part 1 is completed. Part B requires us to use the oscilloscope to measure the phase change caused by a capacitor connected in series with the resistor. So first things, we need a capacitor box. Looks like this. Also, you switch all of them down to make sure none of them are connected and start to connect your circuit. I will connect the circuit first before moving on to the oscilloscope part. So, this requires another 2 phases of the 3-phase power source. So one of them will come from here to the resistor, and the other one coming out of the resistor. I'll use a shorter one for this. Coming out of the resistor and going into the capacitor. And then you have the wire coming out of the capacitor and going back to another phase. So now this circuit is done, but it is not quite done yet because we're going to connect some probe into this circuit. Well, we are not going to use the wattmeter to probe this. We're going to use the oscilloscope, which consists of another set of probe. Those probes are located on top of your bench. So these black bags contain those probes. Let me show you. So in the small bag are the small differential voltage meter. So you can see here, it's a differential voltage meter, means it measures the potential difference between these 2 probes. And then this one goes into the oscilloscope. Before plugging in, let me show you the Hall effect current probe. It's located here. So it's one single black piece, and there's a hole in the middle. And then you can put this back to let a wire in, and then put it back on. You can see here there is a little arrow on the shell of this probe. This means the positive current direction denoted by the oscilloscope. So if you have a current going in the direction of this arrow, it will show as a positive current. Otherwise, it will be a negative current. And for this probe, you pull it, it will open. You put the wire inside this hole, and then you put it back on. Remember to lock it before you take any measurement. So this one, this is the differential voltage probe. Channel 1, you'll hear a beep, that's correct. And then this is the current probe in channel 2. Okay, now you're connected, but it's not done yet. There are a few things we need to do. You need to zero these two probes. So for this voltage probe, you need 2 of these hooks. Connect it here, connect it here, and you need to hook them against each other like this. And then you hit manual here, and then you will see a manual pop up, and then you hit this auto 0. And it's done. Put this aside, and now we have the current probe. And then we need to lock it like this. Now we again need to go to the top right here. This is for the current probe, and you hit the second button from the bottom or from the top. It says degauss. You hit that. Well, it is automatically degaussed. Make sure you auto 0 and degauss both the current probe and the voltage probe every time you use it, because there may be significant error occur if you do not do that. We use these small plugs as terminals for our probe to work. So we put them on each side of the resistor box, and then we hook our probe on it. It's a little bit hard, but do not remove the plastic cover on it because it serves as an insulation. All right, it's now hooked. Another thing we want to do is to measure the current in this circuit, right? Since it's a series, no matter where we measure, it's always going to be the same. So I'll just put it here. Since it's coming out of A phase, I will point this like this. All right, so now we have the entire connection ready. Switch on the 3-phase. I'm going to auto set it since it's not complicated, we'll handle it. So I want to measure source A and phase. Turn off the measure. And then you can see here, there is a -5 degrees phase difference in between. All right, then part 2 is done. I don't know if you can hear, but currently the fan of the resistor box is running. It's spinning very fast. So I think I just put a lot of load on it. Do not unplug this plug or turn off the bench power whenever the fan is rotating, because it will shut off the fan and cause the heat to accumulate. Okay, I'll let you to hear it. Yep, it is running fast. All right, now we are on the part 3 of this lab. It is the most exciting and most interesting thing. We're going to finally run the motor. This is the induction motor, and you're going to do the induction motor lab in lab 4 and 5. and this is the most widely used motor in the world. So today we are only going to let it run and let you to hear it, feel and see it, and we're going to do the detail lab later on. The connection is comparatively simple comparing to the previous parts, and let me show you. So in this one, we really only need to do 3 connections. We are going to use this 3-phase power to power the induction motor. And as you see right here, so there are some connections to the induction motor. Green is the neutral, which is the ground. I think white is the white is the neutral and the green is the ground. Basically the same. And then we have the 3-phase individually going into the induction motor. In order to protect you from this rotating machine, we have this shield right here, acrylic shield, so you do not have direct access to the motor. You can see it spinning, but you cannot touch it. And then these 3 are connected to the bench, and they come out on 3 of the terminals right here. So these 3 connectors are exactly the same one as these 3. If your machine is on the right of the bench, you will see A1 right R, A2 R here, but this one is left, so A1 L, A2 L. So the connection is simple. You connect A1 L, make sure this is turned down, this is turned down, A1 L to A phase, and A2L to B phase, and then A3L to C phase. Okay, make sure you connect everything to the right side of this knob so that you have the control of the Variac. And now we're going to turn on the machine. Switch on the 3-phase mains. Oh, sorry. Before that, we have one other important thing to do. I just forgot it. Since if you can see it right here, the motor is actually connected to a dynamometer. On your right is the black one. The dyno is another DC motor, so it helps to characterize how much torque and how much RPM is created by this motor. And it is also connected somewhere outside, 2 terminals coming out. One thing that will happen when you turn the motor, it will generate some voltage and generate some power on the dyno side. And you need to dissipate those, otherwise it will accumulate inside the motor and it may overheat the motor. So you want to get them out and dissipate them. Here are the terminals coming out. On your left is the dyno control, which goes into the dyno. On your right is the DC mains. DC mains is a plus 120 and minus 120 DC voltage that we're going to use to power the dyno, but not today, later on in the lab. This dyno control goes into the dyno, so we will use the 2 terminals on the dyno control to get the current out. Let me quickly connect this for you. You have 1 plus, 1 minus coming out, and then let me pull the camera backward, and then look down. Here's our omnipotent resistor box. We're going to use the resistor box to dissipate the power, and usually we use 250 ohms to dissipate it, so 2 switch up and connect this in. No need to switch this or this, because this is to control the dyno, which we don't need. This one is to turn on DC mains, which we don't need either. Now we're ready to turn on the motor. All right, I'm gonna switch this on, and I will let you to hear the motor and feel the motor, because you'll probably not be able to see it. The mic here. Turn it in 1 second. If you could not see it from the video, I try to make the video good. But if you still cannot see it, try to look at a yellow connector in the center, yellow coupler. I think you can see it. Otherwise, you will definitely be able to hear it. I have the mic really close to it. Good. All right. So this is all for part C. And now you can turn it down like that. And then switch off 3 mains. And we are done. All right, here is all the procedures for Lab 0 introduction. I hope it will be helpful for your actual lab sessions. And in the future, we're gonna have this kind of video for every lab. It will go through the lab settings, lab setups, how to the connections, so that you will save some time during the lab time. See you next time.